Okay, in this video, let's solve the problem number 26, remove duplicates from the sorted array. So in this problem, we have an array called as nums, and we have to remove the duplicate elements, and relative order should be kept the same. Means the number should be in the order of like it should be in a sequence like 0, 1, 2, 3, 4 and all. So here also what we can do is just rotate to loop through the elements, and then whichever and just put the duplicate elements at the last and bring all the unique elements at the starting. So let's first try it on paper. So we have an array. Let's take the example, second example. The second example is 0, 0, 1, 1, 1, 2, 2, 3, 3, 4, 3, 3, 4. So the how many number of elements? So how many elements does it have? 0, 1, 2, 3, 4, 5, 6, 9. Sorry. Total 10 elements. So this array has 10 elements. So what we can do here is we can check the elements, and then whichever element is not equal to so what we'll do, we'll just run a loop from here. So we'll start a pointer from here, and we'll check the next element. If 0 and if I is equal is if I is not equal to I plus 1, then we will put the element at starting of the index, at the starting of the array. Okay, so what we are doing here is we are just we will compare the elements. Nums of I with nums of I plus 1. So we will check the this element with this element. If it is not equal to this element, then we will put this element at the starting. Okay, so let's see for all elements. At I is equals to 0, 0 is at nums of 0 is 0, and nums of 0 plus 1, which is 0. So is 0 not equal to 0? False. So this condition is false. So let's move the pointer. Is at I is equal to 1, is 0 not equal to 1? True. So in this case what we will do is we will just first we will initialize the k pointer to put the to put this element, unique element, at the starting of the index. So this will be our new array. This will be the same array we are just writing here to for a better understanding. So our k value is 0. So what we will do, nums of k. So initially k is 0, so nums of 0 will become nums of I, which is 0. Now we will move the pointer k plus plus. Now our k pointer is here at one position. Now I is equals to 2. So this is our indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are our indexes. So at I is equal to 2 index, is 1 is not equal to 1? False. So we'll move the pointer ahead. At I is equal to 3, is 1 is not equal to 1, false. Is I at I is equal to 4, is 1 is not equal to 2, true. So when this becomes true, so we again will place nums at k is equals to nums of I, and we'll move the pointer k plus plus. So here at one position what it will become 1. Now our k pointer is at second index. At I is equals to 5, is 2 is not equal to 2, which is false. At I is equals to 6, is 2 is not equal to 3, true. So again what we'll do, we'll just put the 2 here, nums of k, and nums of is equal to nums of k is equal to nums of I, and we'll move the pointer k plus plus. Now k will move to the second index. At I is equals to 7, is 3 not equal to 3, false. We will move the pointer I. At I is equals to 8, is 3 not equal to 4, true. So again we will put nums of k, which is nums of 2 is equals to nums of I. Now we have 3 value here. Now see, when our I pointer is at 9, 4 is not, so we don't have any element after 4. So our when we try, when our nums of I is 4 and nums of I plus 1 will become out of bound, so we will get the error. So what we will do here is, we will just put the element nums of k is equal to nums of n minus 1. After completing the for loop, after the complete iteration, we will just place the last element, we will just copy this element in the new array to, so that we will not left any element. Let's write the code. So here first we will define int n is equal to nums dot length, and also we can add one edge case. If n is not equal to is less than or equal to 1, then we can return n, right? Because if the array has only one element, or one or less than one element, it means that it does not have any duplicate elements, right? So if n is equals to 0, so we have 0 unique element, and if n is less than 1, which means it has only one element, so it will be unique only. And for all cases, we can take k value, k pointer, and we'll run the for loop. I is equals to 0, and we will run the for loop till n minus 1, because if we less than we'll run this loop till till it is less than n minus 1, because if we run it at n, then we are checking the case with n plus 1, checking the variable, checking the elements of nums of I is equals to nums of I plus 1, so it will become, here we are checking the here we have a, so here we are in our condition, compare here condition, we have I plus 1, so it will be out of bound. That is why we are running the loop using the loop condition as less than n minus 1, and we'll compare it. If nums of I is not equal to nums of I plus 1, then we'll place that element at the starting, and we'll move the pointer by k. After the loop, we will just place the last remaining element k nums of n minus 1 at k position, and we will just return. So we have to return the number of unique elements. So if our index so this k is the index, so to return the number of elements we just have to add 1. Okay, so time limit exceeded y. Okay, so here I did not move the pointer. I got the answer. Let's submit it. Beats 82.93% of users with Java. So that's it. Let's solve the next problem.